I gotta go find 6. All right, guys, we're going to do 45 and 46. This is radioactive decay. This is how we figure out how old things are, and you always need to have a half-life to make that work, okay? So let's look at number 45. You found a fossil in your backyard. By the way, make sure you read the question. After testing, it is determined that there is 64% of the original radium-226. That's an element. How old is your fossil? So let's take a look. All right. Half-life is 50%, okay? And the formula you always use is A equals P E raised to the RT, because it is an exponential decay, and it is continuous because things don't just decay for 5 minutes and they stop, and then they go, oh, I'll start again, and they stop. Oh, I'll start. No. Decay continues all the time, continuously, okay? That's why we have bones. Human body turns to bones, animals turns to bones, and you can kind of tell how old something is. All right. So first of all, you know that it's going to be at 50% out of 100. I start off with 100, end with a 50%. Now, it tells you the rate. Well, I don't know what that rate is. I don't know how long it's taking it to get at that half-life, but I know the half-life is at 1600. See how we just did that? So now we're going to go and find the rate. How fast is it decaying? And so, in order to do that, we are now going to divide by 100. Okay? So that leaves you 0.5 equals E raised to the 1600R. I just reverse those because I like my letters, my variables after my numbers, my constant. And now that you learn how to solve for R, you can now rewrite it. So we're going to do log base E of 0.5. My base is E of 0.5 equals 1600R. Instead of log base E, I can change that to natural log. Go to your calculator. Okay, let me clear that. So natural log, remember, it's one button, ln 0.5, and that gives you negative 0.693 equals 1600R. Okay, so step 1, find the rate, which is R. How do you solve? Divide both sides by 1600. And what is R equal to? So what is the rate of decay? So R is equal to, I will be looking for this answer, negative 4.332. Okay, see how I'm writing it? 4 decimal places, negative 4.332. You see that E right there? That's the same as times 10 to the negative 4. Okay? So there is the rate that I will be looking for. Now that you know how fast it is decaying, you can now use that information to find how old it is. All right, so you ready? Same formula. It tells you you have 64% left out of 100. My rate is negative 4.332 times 10 to the negative 4 times t, because I want to know how old, and t is time. Okay? All right. So divide by 64. No, I lied. Divide by 100. That leaves you 0.64 equals E raised to the negative 4.332 times 10 to the negative 4t. Okay? Rewrite it. So this will be natural log, because log base E of 0.64 equals negative 4.332 times 10 to the negative 4t. And if you need to put parentheses around it to help you better, that's fine. All right, go to your calculator. Natural log of 0.64 is that number. 4 decimal places, negative 0.4463 equals negative 0.4332 times 10 to the negative 4t. How do you solve? Divide by that. What you do to one side, you do to the other. okay? Alrighty, and I'm gonna come down here. Sorry, I'm out of room. And you can just type that in. Ready? See, I already have that number there. Divide. Now let me show you how to type this part in. Okay, you ready? Negative 4.332 times 10 is this button right here. See the comma? It's right above it. You see how it's blue? So second comma. See how the E comes up? Negative 4. So how old, so T is equal, how old is that artifact? 1030.2103, 4 decimal places, years old. It's over 1,000 years old. Hey, look, it's older than you and me. Okay? Just barely. All right, and there you have number 45. So find the rate and then find the time. Okay, so use that rate to find the time. All right, and there you have number 45. Okay, let's do 46, same way. Here we go. You find a fossil on a hiking trip and you have tested in the lab. It is determined to have 19% of its plutonium, that's element 238 remaining. How old is the fossil? Notice I'm asking how old. I didn't say what is the rate of decay. Same scenario, 50% out of 100. Why? Because it's a half-life of E. I don't know what R is, but half-life of that is 88 years old. Okay? So divide by 100. 0.5 equals E raised to the 88R. Notice my base is E, so I'm going to use natural log of 0.5 and bring down my exponent. Go to my calculator. What is natural log of 0.5? Negative 0.6931 equals 88R. How do you solve for that? Divide by 88. So what is your rate? So I'm going to divide by 88. All right, see this one doesn't have an E, so you just need to do 4 decimal places. 0079. That's how fast it is decaying. Okay, it's actually decaying faster than number 45. All right. The question says how old, so now I'm going to use this rate to help me find how old it is. It only has 19%. Now remember, a percent is out of 100. That's why 19 was 100 at the rate of negative 0.0079 t. Okay? Divide both sides by 100. So 0.19 equals E raised to the negative 0.0079 t. E is your base, so I'm going to use natural log of 0.19. Bring down my exponent. All right. Go to your calculator and see what the natural log of 0.19 is. Negative 1.6607 equals negative 0.0079 t. How do you solve for t? Divide both sides by negative 0.0079. What you do to one side, you do to the other side. Okay? So see, I already have that number. So I'm going to push divide. Negative 0.0079. Just like that. So how old is that artifact? 210.2191. Don't forget your label. Years old. Okay, make sure you identify what they are. All right, if you just put 210, I'll be happy. If you just put 10,000, 1,030, that'd be fine. And there you have your solution for number 46. Find your rate first and use that rate to help you find how old it is. Okay, good luck, guys.